Okay, so we're over now on page 35. I'm looking at example 5, where it says equations involving two variables. And it's a word problem. And actually, this particular word problem is going to end up having three variables, as I'm going to show you. But let's read through it. So it's a travel problem. It says Amelia drives an average of 65 miles per hour. Write and solve an equation to find the time it will take her to drive 36 miles. Now, this involves a formula that you'll use many times. You'll use it in math, and you're going to also use it in science. At least you will in my physical science class when we start talking about motion. And that formula, I'm going to write it this way first, and then I'll rewrite it, is rate equals distance over time. And rate we often use, particularly in physical science, instead of R, although we use velocity. Velocity equals distance over time. And velocity is rate of speed, rate of change. And if I rewrite this formula, and I'm not going to go over the mechanics of rewriting it at this time, we'll have another chance to do that. We can go, let's see, we're trying to solve for time. Time equals distance over rate or velocity. All right, so now that we've got this, and I hope that's not confusing. I don't really like this problem because it didn't take you through the distance formula. But let's plug in what we've got. So we're trying to solve for time. So that's our T. And we see here that Amelia has driven, she drives an average of 65 miles per hour. That's going to be our velocity. And she's driven 36 miles. So that's her distance. So we've got T equals 36 over 65. And that'll actually give us the time. I'll get my little trusty calculator out here. And if I take 36 and divide it by 65, I'm going to find that time, and it's a decimal carried out about 6 places. I'm going to just round it to 2 places. And it's not equal to this. It is approximately, and I make that by the little squiggly lines instead of an equal sign, is approximately 0.55 hours. Now, let's plug in something else here. This is miles, and this is miles per hour. And my miles will cancel out, and it leaves me with just hours. So, to drive 36 miles at 65 miles an hour is going to take you about a little bit more than a half an hour. Well, I noticed when I was previewing that previous slide that I had been watching the U.S. Open golf tournament when I recorded this, and I could hear it going on in the background because I had failed to mute the television. And I didn't really feel like reshooting the video, so hope you enjoyed talking about bogeys and stuff like that, if you heard it in the background. Now, we've got another word problem here. Let me back up on that previous slide. In your notes, you should go ahead and record this speed problem or velocity problem, which we can manipulate to be a distance problem or even a time problem. And you should record that in your notes because you're going to see this pretty often. And that is velocity or rate of speed, depends on whether you use V or R as your variable. Velocity equals distance over time. D for distance, T for time. Let me encourage you to get that recorded in your notes while I'm thinking about it before I get away from it. Now, let's just go ahead and tackle this word problem. And it's not It doesn't really have a formula like the last one did. But we're going to assign some variables and then solve it. So we got San Francisco as a recycling facility that accepts unused paint. Okay, so this is a fact. It says volunteers blend and mix paint and give it away in 5-gallon buckets. So we got a 5-gallon bucket here that we want to be thinking about. And it says write and solve an equation to find the number of buckets of paint. So we're looking to find the number of buckets of paint. That's what we want to find. Given away, they're giving away 5-gallon buckets right here from the 30,000 buckets that were donated. So let's just assign some variables right quick. Well, we got, let's say that B is equal to a number of buckets. That's what we're trying to find. And we've got 30,000 donated buckets. Let's give that a value. Let's give that a variable D, donated buckets. And then we've got 5-gallon buckets. Let's just call that, and we'll just call that G. All right, so let's fill in what we know. Buckets is what we're trying to find. And we got 30,000 donated buckets. And we're giving away 5-gallon buckets. So in order to find the number of buckets that we're giving away, B, we can take 30,000 and divide it by 5. And so we're going to give away, let's see, how many we got here? 6,000 buckets. That's what it looks like. Yeah, 6,000. 30,000 divided by 5 is 6,000. So we're going to give away 6,000 buckets. When you're looking at a word problem, you got to try to break it down. I know students hate word problems. I don't really care for them either. They're going to show up on SATs and things like that, though, as you move ahead. So we need a little practice in it. So here we went ahead, we assigned some variables, B for buckets, the number we're going to give away, D for the donated buckets, G for the 5-gallon buckets, because we're giving away 5-gallon buckets. And if we get 30,000 buckets of paint in, we're going to end up giving away 6,000 buckets. All right.